Have you ever felt like your beach vacation dragged on forever while your trip to the mountains flew by in an instant? It turns out, your perception might be more real than you think. Scientifically speaking, time actually does flow differently depending on where you are. If you spent your entire life on the peak of Mount Everest, you would physically be slightly older than your twin sibling who stayed at sea level. This isn't just about fresh air or perspective. It's about the fundamental fabric of reality itself. To understand this, we need to travel back to 1915.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
This is when Albert Einstein published his theory of general relativity, completely changing how we understand the universe. Before him, we thought time was a constant river, flowing the same for everyone. Einstein asked us to imagine the universe not as empty space, but as a fabric, a giant trampoline. When you place a heavy object, like our Earth, onto this fabric, it curves and stretches. Crucially, this massive weight doesn't just warp space, it warps time along with it. This phenomenon is what physicists call gravitational time dilation. The rule is simple but mind-bending. The closer you are to a massive object, the stronger its gravity pulls, and the slower time itself moves. Gravity is literally dragging on the seconds, holding them back. According to the National Institute of Standards and Technology, time moves faster the further you get from the ground. Your head is actually aging faster than your feet right now. But how do we know this for sure? We use atomic clocks. These aren't normal watches. They count the vibration of cesium atoms to measure time with accuracy down to the nanosecond. In a famous 2010 experiment, researchers proved Einstein right again. They placed two identical atomic clocks just 33 centimeters apart vertically, about 1 foot. Even over that tiny distance, the higher clock ticked faster than the lower one. The difference was almost impossible to detect, but it was there. Gravity's grip was slightly weaker, just 1 foot up. You might think, who cares about a billionth of a second? Well, your smartphone does. In fact, modern civilization depends on this fact. Consider the GPS satellites orbiting 20,000 kilometers above us. Up there, Earth's gravity is much weaker than it is here on the ground. It's actually a battle of physics. Because they are moving fast, special relativity says their clocks should slow down. But because gravity is weak, general relativity says they should speed up. The weak gravity effect wins. Without correction, satellite clocks would run about 45 microseconds faster every single day compared to clocks on Earth. If engineers didn't program the satellites to mathematically correct for Einstein's theory, the entire GPS system would fail. Your location accuracy would drift by kilometers within 24 hours. So, if you want to maximize your lifespan, living in a basement by the beach is technically your best bet. But we're talking about fractions of a second over 80 years. It makes you wonder, though, if we ever colonize a massive super-Earth, time dilation wouldn't just be a scientific quirk, it would be a way of life. Thanks for watching.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.